In this tutorial, I'm going to show you how to create a standalone LVM virtual server in Linux. Some of you may be wondering, what the hell is that? Well, I'm sure most of you are familiar with a virtual machine. The problem is running a virtual machine locally, you're forced to use your own system resources, assuming you even have adequate hardware, and can't realistically have it running 24/7. By creating a standalone virtual server, you'll be able to create multiple virtual instances at any time and run it on a dedicated server so that you don't have to utilize your own system resources. We'll be using an LVM or logical volume manager to increase flexibility. An LVM is an abstract partition manager comparable to Windows dynamic disks or VHDs. Basically, rather than partition our physical hard disk, you work with a software volume manager that splits everything up into volume groups and logical volumes. I plan on making a tutorial at a later time to further discuss LVM, so don't worry too much about that right now. You're going to need a couple things for this tutorial. A spare computer or server, preferably one with at least a dual core, quad, 6 or octa core would be preferred. At least 2 gigs of RAM, of course the more the merrier, and at least 2 hard drives. Remember, a server is just a term to describe a device that serves requests to other clients, so you don't need any U1 blades or expensive equipment to actually build a server. We're also going to need a Linux ISO installer. We'll be using CentOS 6.2 in this tutorial, and I highly recommend you do the same. CentOS is essentially a free version of Red Hat Linux and is considered a standard for enterprise networks. Working with an enterprise distro will prove very useful in your future career endeavors. You're going to also need, of course, a network connection. I'll be using a minimal installation image of CentOS, which is basically a stripped down bare-bone ISO. I'm assuming a majority of the audience won't be working with high-end servers, so we want to work with the bare essentials to free up resources and only install what is needed. I will also be creating the server via CLI rather than using a GUI. CLI offers numerous advantages over GUI, and we want to limit the host resource usage as well. As always, links to all the resources used in this video can be found in the video description, as well as the syntax used throughout the video. With that said, let's get started. I've created 2 40GB IDE virtual hard disks to use in this demonstration. These will act as our physical disks. I'm just using virtual disks so I can show you the installation process itself. You'll need to boot from your Linux installation ISO, so simply burn the ISO to a CD or DVD and ensure it's your first boot device to boot from the installation disk. Anytime you're burning a Linux ISO, I recommend doing so at 8x speed to avoid corruption. Also, if the server CPU you are using has virtualization technology such as Intel VT, ensure it's enabled in the system BIOS to improve performance. So right now I'm booting my server from the CentOS minimal install image. I'm going to go ahead and choose the option to install or upgrade an existing system, and it will begin loading all the content into memory. The first screen I'm going to get during the installation is a disk found message, basically saying that it found some media and do you want to test it to ensure that it's not corrupted. I already know my installation image is fine, so I'm going to go ahead and skip this step. You can test it if you like. I recommend just skipping it though. And now we have our Anaconda installer starting. This will bring us to a GUI where we can walk through the installation steps. It's pretty straightforward, but I'll walk you through each one of these. I'm going to go ahead and use English because I speak English clearly. I'm going to use US English since I'm using an English keyboard. And I'm just going to select basic storage devices. I don't plan on using any kind of SANs or anything like that. So since we work with IDE, just choose basic storage devices. Hit next. I'm going to do a fresh installation, so I'll have that radio button checked and hit next. Host name doesn't really matter. I'm just going to name it VV LVM server. Also, one thing I found is you want to click this configure network button, then select the Ethernet device, hit edit, and then hit apply. If you don't do this, whenever the server comes up initially, the network interface won't actually be up, and it won't even know whether or not to use DHCP or what protocol to use. You have to manually configure all that. So to save yourself a headache, just make sure you do that step, and then once all that's done, just click next. From here you can go and select your time zone. I don't really give a fuck, so I'm just going to hit next. Root password. For the root password, I'm just going to set a sample password of password, but I highly recommend you use something very complex or secure. It's going to probably give me a message here saying it's a weak password. I'm going to go ahead and use anyway. Which type of installation would you like? We're going to end up creating a custom layout, but just to make things easier and quicker, click on use all space. This way it'll automatically create an LVM group for us, and then click the button to review and modify partition layout. Once that's done, just click next. It's going to present the hard drives in your system. In this tutorial, we're assuming you're using at least 2 hard disks, so go ahead and add both of those hard drives to the installed target devices. Whichever one, if you have two different drives, whichever one you want to be your primary disk, ensure the bootloader radio button's checked for it. Otherwise, just put them both over there and let it do its thing. The first thing I want to do is I want to edit the sizes of the partitions we have. I have a 40 gigabyte hard disk, so that means I'm going to have a 20 gig root partition, a 10 gig home partition, and a 6 gig swap partition. Typically your swap is going to be 150% of the RAM in your system, so that is assuming you're using 4 gigs, which equates to 6 gigs. So let's go ahead and do that first. You can just click on the partition you wish to customize, then click the edit button. So for my root partition, I'm going to go ahead and increase this up to 20 gigs, which is 248, or 248, 20,480 megabytes. Hit OK. Then let's do the same for my home partition. Set it to 10, which equates to this. And do the same with my swap. Swap, I'm going to set for 6 gigs, which equates to this. Alright, so now we have the size set for our partitions. The next thing we want to do is we want to customize the naming scheme of our volume group, as well as make some adjustments to the volume group. So I can go ahead and click edit on this. You see that it by default will associate both the disk drives to that volume group. We want to go ahead and remove one of those from that volume group, and then also we want to increase the physical extent size so that we can later on increase the size of our system. If you plan on using 1 terabyte or more, you're going to want to make sure you have 16 megabytes selected. Once you've done that, you can go ahead and rename the volume group. Typical naming scheme is going to be VG0 for volume group 0, or the first volume group, and then underscore some sort of label. So for this is going to be VG0 host, because this volume group is going to be specific to the host operating system. Once that's done, you can go ahead and click OK. Now we want to go ahead and name or edit the naming schemes for our actual logical volumes. So for our root, let's go ahead and edit this guy, and we're going to change it to LV0 underscore 0 underscore root. So basically saying that it is the logical volume of volume group 0, and it is number 0 in that volume group. So once I've done that, click OK. I'm going to do the same thing for my home. Let's go ahead and edit the naming format for this. This is going to be 1, and then swap I'm going to make 2. So right now we see we have a single volume group for a host system, and we have our swap, root, and home partitions or logical volumes associated to that volume group, and only SDA1 is associated to that volume group. So with that said, 500 megabytes should suffice for our boot partition. We'll go ahead and leave that as is. You see here our SDA2, the second partition on that disk, is associated to the volume group, and then SDB, our second hard disk, we're going to go ahead and change to not LVM, but rather ext4 file system. And we're going to use fill to maximum allowable size, so basically changing the file system the entire hard disk, and then we can just click OK. Once that's done, you can just click next. Partition options you have selected will now be written to disk. Yes, you want to do that. So go ahead and write changes to disk. Once all those partitions are formatted and all that good stuff's done, it'll bring us to the bootloader operating system list. Go ahead and just leave this as the default. All it's saying is you're going to install the bootloader at this location. That's fine. We want it to install on the first hard disk on that logical volume. So leave that alone and then click next. We now see the installation is beginning, so it's writing all the contents of the CentOS image to the partitions that we laid out. This may take a few moments, so we'll go ahead and let it do its thing. Once the installer finishes doing its thing, it's going to bring you to a screen saying, "Congratulations, your CentOS installation is complete." At this point, you can just go and reboot your system, and it should bring you up to run level 3 to log in and start setting up the VirtualBox system. So let's go ahead and do that now. See here, it's bringing us to a boot menu. We don't need to actually boot anything else, so we'll go ahead and let it boot into CentOS. And here's the loading bar showing that the operating system is loading up. And here we are at the CLI. So at this point I can go ahead and log in. I'm just going to go ahead and log in as root. They advise that you don't log in as root, you just log in as a generic user, but we don't have a generic user, so let's go and just log in as root. We can make another user after we get everything set up. password. Alright, and we're now at the prompt, so we can begin the installation. We're going to be using VirtualBox as our virtualization software. We're not going to be using hardware virtualization for this because that's going to require specific hardware, so we want this to work for a wide audience. Really, hardware virtualization is going to improve performance slightly, but if you're not trying to work on an enterprise solution, it really shouldn't be that big of a deal. So VirtualBox is going to need to build kernel modules, so we'll need to use a dynamic kernel module support as well as some additional tools that do not come packaged with CentOS by default, and we're going to need to download those to get VirtualBox installed correctly. Before doing so though, let's go ahead and update our system so we can work with a current operating system. To do that, just type in yum update and it will begin the update process for you. And in this case, it looks like I may not have internet connectivity. Yeah, so during the installation process, I told you to click on the configure network to ensure DHCP was on. This is the exact issue I was talking about where it doesn't recognize the Ethernet adapter, so it's a relatively simple fix. You can just do if config eth0 up, and then actually DH client eth0. So basically you're saying I want my first interface to come up and then go ahead and request a DHCP lease on that interface. And then if we check out eth0, we see that we now have an IP address. Also, just to ensure that it continuously uses DHCP to get an IP address, or if you want, you can statically set an IP for it. You're going to need to update something here really quick, so let me show you how to do that. The minimal install doesn't come with many text editors, so what we're going to have to use is VI, which can be a little tricky at sometimes. Typically I like using Nano, but we'll just use VI for this. So let's do VI /etc /sysconfig, and then network scripts. Come on, autocomplete. There we go. And then if CFG, and then the name of your interface, eth0 in this case. And hit enter. Then we can go down to boot proto. It's set for DHCP. That's exactly what we want to do. If you don't actually go into the click on configure network, the boot proto won't actually be there. I'm not too sure why it didn't give me a DHCP lease initially, but in either case, when I reboot, it should give me a DHCP lease. If you wanted to set a static IP on it, you can change the boot proto to static and then input IP ADDR equals and then IP address, and do the same for broadcast, netmask, and network, which will be your network ID. So we'll go ahead and cancel out. So we need to send an interrupt signal. Alrighty. So we're back at our prompt now, and we can go ahead and move forward. We should have internet connectivity. Let me go ahead and just verify that. Okay, we're good. So let's go ahead and begin the update process again. Alright, we can see it's doing its thing here, so we'll give this a few moments. Alright, so now we can see the update is complete. Now that the system's updated though, we can go ahead and install those additional tools and the DKMS that we needed. So to do that, we can use yum. Let's just do yum group install development tools. Alright, and some of this is covered on the CentOS wiki, I believe. It's going to go ahead and give us a package we can download. It has 113 packages in it. Some of these aren't really required, but there are quite a few that are, so we're just going to go ahead and download the entire group, and then click Y for yes, or actually press Y for yes rather. And then we can see it's downloading all the RPM packages to install those additional tools. So let's go ahead and let it do its thing here. Alright, so the development tools are now installed. Next, we want to install a few additional tools like wget, which we'll need. I'm also going to install Nano, which is a text editor. If you're comfortable using VI though, you don't have to include Nano in your install. And then I'm also going to include yum priorities. So let's go ahead and do that now. Yum priorities, Nano, and wget. So we're downloading those three items. Go ahead and click Y. I want to download them. Alright, and the installation is complete. Next, we want to go ahead and change to our temp directory so we can download something here. I'm going to go ahead and download an RPM so that we can get the DKMS that we need. So to do that, wget http:// and we're going to use packages.sw.be. So RPM forge release and RPM forge release 0.5.2-2.e16.rf. Alright, kind of a long string there, but go ahead and type that in, hit enter, and it will download that for you unless I mistyped it. Actually, I made a little goof here. It should be rpm forge -release -0.2-2-2-el6.rf.x86_64.rpm. Little confusing and cryptic, but just use a link in my video description. That'll be the accurate one, and you should be good. So once I have that typed in correctly, hit enter, and it should download and do its thing. There we go. And then next, we can go ahead and do an RPM import. So go ahead and type in this here so we can get the GPG key, dag.txt, and then hit enter. That should be SW. I have a mechanical keyboard, so I make typos a lot. Alright, there we go. That's done. And now we can do the installation. So RPM -I, RPM forge, and then just hit tab so it auto-completes, and then just hit enter. Alright, and then next we want to install the DKMS. So yum install DKMS, and then hit enter. Next, we need to format our second hard disk so that we can associate it to a second LVM volume group. To do that, we're going to use fdisk, so I'm going to type in fdisk/dev/sdb1, which is my second hard disk. Hit enter. I want to type N for new partition. I want it to be a primary partition, so I type P and then hit enter. Partition number, it's going to be partition 1, then hit enter. We can go ahead and use the default first cylinder, so just hit enter. We can use the default last cylinder as well, so let's hit enter. And then once that's done, type in T. And the hex code for the file system is going to be 8E, which is for LVM. And hit enter. And W, so we can write this. And now we just need to do a quick reboot so that partition scheme takes effect. So just type in reboot and hit enter, and the system should reboot for you. Alright, now that the system's rebooted, I can go ahead and log back in here. Log in as root. And now I can begin creating my second volume group. So first I'm going to do is add a physical volume. So pv create, and then specify my second hard disk, which is /dev/sdb1. So pv create /dev/sdb1 and hit enter. Alright, says it's successfully created. Now I can create the volume group. So vg create for volume group create -s. We're going to use 16 megabytes as we did with our first volume group. We're going to name this one VG1 instead of VG0 underscore, and we can go ahead and name it VM. So the first one was VG0 underscore host. This one is going to be VG1 underscore VM. And then once we have that typed in, we can specify our disk. So VG create -s 16 megs space VG1 underscore VM, and then space our hard disk /dev/sdb1. Once you have that in, hit enter, say it's successfully created. Now we can create our logical volume, so lv create -l. We're going to make this guy 20 gigs for this. You can make it whatever size. I understand you guys aren't going to be using 40 gig hard drives, so if you want to create 100 gig, 200 gig, whatever, the more the merrier, go ahead and do it. The nice thing about LVM is you can expand and reduce the volume sizes whenever you like. So if you do make it too small or too large, you can always change it at a later time. But in this example, I'm just going to use 20. And then space hyphen lowercase n. And we'll name this one logical volume 1 underscore VM. So logical volume associated to volume group 1, it is the first actually let's change that to 0. It's going to be the first logical volume in that group, and it's for our virtual machines. So once you have that, hit enter. Oh, actually I'm missing the name of my volume group, so let me add that in here. VG1_VM. So LV create, the size of the partition, the name of the logical volume, and space the volume group name that you want it associated to. Once you've done that, hit enter. It'll say it's created at this point. And now what we can go ahead and do is change the file system on that to ext4. So to do that, we can use mkfs, ext4, 1, block size 1, dev, vg, actually, VM, and then logical volume 1_0, gosh, VM. Okay. And then it's do its thing there. Alright, there you go. Now you have a ext4 file system on that logical volume. Next, we want to go ahead and mount that logical volume to the directory where our VirtualBox virtual machines will be created. By default, VirtualBox on Linux is going to install it in the home directory. Since we're root, that will be /root, and a directory called VirtualBox VMs. So what we're going to do is we're going to mount this at VirtualBox VM, so whenever it's writing to that directory, it's actually going to be writing to this LV partition. So to do that, we're going to go ahead and use the mount command. Mount t ext4, which I don't think we need to even use anymore. Dev vg1_vm hyphen lv1_0_vm, and then mount it at this location. Actually, we need to put in there you go. So we're mounting ext4 file system of our logical volume group to the /root/VirtualBox VMs directory. So go ahead and do that. Actually, I need to create that directory first. So since I haven't installed VirtualBox, I need to actually create that directory beforehand to be able to mount it to that point. So to do that, I'll do mkdir /root/VirtualBox VMs and encapsulate it within quotation marks. And now I can mount it. I'll need to update Fstab with this information to ensure that it mounts after a reboot. So let's go ahead and do that now. I went ahead and downloaded and installed Nano earlier, so I can use Nano now instead of VI. And so what I'll do is nano etc fstab, and we'll just add an extra line here. Dev mapper is going to be a symbolic link that points to your logical volume, so it's going to be /dev/mapper/vg1_vm, and then the name of the volume group, lv1_vm. Okay, and then where is our mount point? We're going to go ahead and set the mount point to where it's currently mounted, VirtualBox VMs. And we're going to set it to ext4 defaults and do 0.2. Alright, so now it's updated in Fstab. So next we can go ahead and change directories to our yum repository so that we can download VirtualBox. So I'll do a wget http VirtualBox. Jeez. HDL. Okay, so wget http://download.virtualbox.org/virtualbox/rpm/rhel/virtualbox.repo. Go ahead and do that. And of course, there's another typo because I'm just notorious for that today. Let's see here. Unless my DNS is just not working, which I thought we resolved DNS. Oh. Looks like it didn't get a DHCP lease again. Lovely. Whenever you set up a server, you want to use a static IP address anyways. So what I'm going to go ahead and do is just set a static IP on this guy. So if config e0, we'll do 192.168.150.128. Net mask is going to be 255.255/24. There we go. So now we have a static IP. We don't have to worry about that anymore. Let's try this again. Alright, so we got the repo downloaded. Now we can do an install VirtualBox. So yum install VirtualBox -4.1. It's going to go ahead and download and do its thing here, so let's give it a moment. Yes, I want to download it. Alright, so VirtualBox is now installed. Let's go ahead and just clear here. And let's take a look at our LVM system just so we can get an overview of what all we've done so far. So I'm going to type in LVM. Let's do an LVS, or actually let's do a VGS first. So as you can see here, we have our VG0_host, which is our first volume group dedicated to our host operating system. And then we have VG1_VM, which is the second volume group dedicated to our virtual machines. Furthermore, we can do an LVS. We see our root, home, and swap logical volumes are associated to VG0, and then we also see that we have a VM logical volume as well associated to our VM volume group. You can use this LVM tool here and type help to see all your options, or let's do more. Really? Well, you're going to have a bigger screen, so it shouldn't be as big of a problem. But this will outline all the commands they can work with. So if you need to manage your LVMs or extend it, like you want to add some additional disk drives, this would be the place to go to do that. Now that we have VirtualBox installed and our operating system installed, we essentially at this point have a virtual machine server that can act as a standalone system that we can use to just launch virtual machines whenever we want to. Now, as far as creating virtual machines on the system, there's a couple ways you can do that. The problem with actually creating a customized system from scratch is most installers have some sort of GUI installing that you have to go through. VirtualBox has something called VRDE, which can be used to output that installation display to a remote device, a remote system, or if you're on run level 5 or have Xserver running, you can actually do that through your host system as well. But in this case, since we're running run level 3, what we're going to be doing is we're going to either be creating virtual disks locally and then transferring them to this system via SCP or some tool like that, or you can just download pre-compiled VDMKs or virtual machines and just load them into this that way. So let's go ahead and use one of those examples. I'm going to use an existing VDMK I have to launch a virtual machine on this system and actually connect to it from a remote system via SSH. So I'm going to go ahead and show you how to do that right now. I've gone ahead and created a virtual image for Router OS, which is a kind of a customized Linux distro for networking. It's essentially a router, but a Linux platform as well. I went ahead and customized the VirtualBox image of that and put it on my YouTube directory on my website, theunderground.com. So I'm going to go ahead and download that virtual image and import it into VirtualBox. Now, anytime you've created a VirtualBox that you want to import into your virtual server, you can just use the export utility on VirtualBox. So I'm going to go ahead and show you how to download and import that virtual machine here. I'm going to go ahead and wget on my website. Let's see, routerOS.ova. The exported image contains compressed VDMKs, which are the virtual hard disks as well. So once we get this entire image, we can just import it with it. We can import it into VirtualBox, and it'll already register and everything. And at that point, we can just start the virtual machine. I'm also going to show you how to modify an existing virtual machine so that it will set it to bridge mode. Alright, so my OVA file is now downloaded, and as you see, I'm in my VirtualBox VM directory as well. So at this point, I can use the vbox manage command to import the OVA file. So vbox manage space import space routeros.ova. Let's Gonna go ahead and import it. It says it's successfully imported. At this point, I can go ahead and start my virtual machines. Now, as far as starting the virtual machine, there's a few methods of doing this. There's VRDE, which outputs installation GUI onto a remote display. I'm not going to cover that in this tutorial, but if you're interested in it, just Google VRDE VirtualBox, and there's going to be plenty of material out there. But how we're going to do this, since we're doing everything through CLI, is I'm going to start it in what's called headless mode, which is basically going to have it run in the background. To do that, I can just type in VBox headless, and then -- start VM, and the name of my VM, which is router OS in this case, -- VRDE equals off. So I do not want VRDE, I do not want to output my display, I just want to start it in headless mode, and I just hit enter. So if you see the copyright information right here, you know the virtual machine's running. So at this point, I'm going to open up another screen, so Control-Alt-F2, and I'm going to verify that my virtual machine is running. To do this, now what makes this difficult is I don't know what IP is going to be on this virtual machine since it's going to be using DHCP. But to find that out, I can use a command called ARP Scan, and that doesn't come pre-installed with this, so you're going to need to do a yum install ARP Scan. And I think I already installed it here. Yeah, it's already installed. Once it is installed, though, you can just do ARP Scan and then -- localnet. And it's going to scan your local area network to find the MAC and IPs on the network. As you can see here, my I'm.2, .1 is my gateway, and of course .254 is not going to be it either. So 132 I know is going to be the IP. So at this point, I can go ahead and SSH into my router OS. And the default username on this is admin. Default password is just password. So SSH admin at 192.168.150.132. Yes. Password. And as you see, I'm now in my virtual system. Now I could run multiple virtual instances on this server at the same time. So if I want to have RadOS running, I want to have Ubuntu running, I want to have another CentOS virtual server running, I could do that. I mean, the more RAM you have, the more virtual machines you're going to be able to run. So if I want 5 virtual machines running, that's all great. I start them on my virtual machine, and then I can, as long as I'm on the same subnet, I can SSH to them from my desktop computer rather than connecting through the host server. So if I'm not, if say for example I'm at a completely separate computer and I wanted to SSH to the system, I could simply type in SSH space admin at an IP, bam, SSH session connected. I can go ahead and do whatever I want to do on that system and be done with it. Now just to eliminate any issues you may run into, I'm going to go ahead and show you how to modify an existing virtual machine to set it to bridge mode. That way it can get an IP address off your current local network. So to do that, let's say, for instance, let's work with RouterOS. Even though it's already configured as that, let's say you downloaded a pre-configured virtual hard disk and you want to set it up for bridge mode. So what you'll do is you'll use VBox manage, and you can modify VM, and then the name of the VM, in this case RouterOS, --nic1 bridged. Actually it's already running, so I won't be able to do that. Also you want to do nic2 none, which basically turns off that NIC. Now if you want to have it running, that's fine. Once you have the bridge mode set though, you're going to need to type in bridge, I think it's bridge interface 1, and then specify the interface on your host machine. So basically what this is saying is my first bridged interface, I want to be talking on this host interface. So that's how you would do that. Also, anytime if you're not importing, if you're just copying over a VDMK or whatever kind of virtual hard disk you have, you're going to need to register that with VirtualBox. And to do that, you can do VBox manage register VM, and then just whatever you want to call it. But anytime if you're dealing with just exports and imports, you really shouldn't have to do that. So that's basically it. There is a lot of VBox commands out there. I wish I could cover them all within this tutorial, but honestly it would take hours to even try to cover them all. So I'll put the link to the page overview in VBox Manage in the video description. I highly recommend you go through there and read through all that so you can see how you can create virtual hard disks without actually doing importing or exporting, how you attach additional storage devices, and just see some of the cool stuff out there that you can do with the virtual machines. But that's pretty much it. Hope you all enjoyed this tutorial and hope you guys have a lot of fun with this.